Okay, this is TempleOS 5-minute random code walkthrough episode 75. And I'm your host, Terry Davis. So let's see where we are. We are in the demo pick. So when we run this, it says it lets us grab the apple. And if you look carefully, it will tell us what sub element is. Okay, element 23, element 2, element 2, and it's telling the distance squared, I guess, to the sub element. I'm not sure. So these are made up of vectors, and this is telling the individual vector number. I don't know why it's so crazy, but it does allow that. I guess it was not very hard to add. So if we look at the apple, there are 1, 2, 3, 4, 5, 6. You can see over here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about, I don't know, 25 vectors. And so that's what it's printing, is the subvector. So I guess let's go through this. We do the standard settings push, settings pop. Once you do that, you can start changing stuff like clearing the window, changing the draw it callback, the window inhibit. Window inhibit is when you start clicking stuff. You don't want, let's say there was a link on the text background, you wouldn't want it to activate. So this turns off links and stuff like that. We have a draw it. Okay, then in the main loop we get a message. The message is everything gets thrown out except key down and left button down. And if it's key down, then we go ahead and jump to the exit. You don't want to jump out of you don't want to go out of try. You have to stay within. So we get the key up. We have to get the key up, otherwise the key up would happen after we exit, and that would be bad because the escape would get forwarded to the command line and kill it. So if it's a key down, we exit. Otherwise, if it's a left button down, then we get the current XY off of global variables. We could have taken them from the args. I don't know why I didn't use the arg. Anyway, record the old XY. Wait a minute. I think we're trying to find the best apple distance. Okay, so we have to hold the button down and carry it. Oh, where do we print the element distance squared? Oh, we set a buffer that gets printed in the draw it callback. So we set some text. This is kind of squirrely. And it's the element number and the distance. Okay, well, old distance, best distance. So the old distance is so that the old XY is so that we can move it. So we can move it. Now we're going to go ahead and, as long as it's not a key down, if it's key down, we bail out. If it's move or left up, okay, we decided not to use the args. We're using the global variables for X and Y. Arg1 is X, Arg2 is Y, relative to the window. IP position X is absolute screen address, and so this is setting. Okay, so best is the current apple, and we are adjusting the XY of the current apple, we record the starting point and we give it an offset. How did we manage to figure out how did we manage to figure out cur apple? That's a mystery. How did we get that? So I'm figuring out cur apple inside the draw it. Oh, that's kind of squirrely. So I go through the apples. I calculate. When I draw it, I get the distance from cur XY. I think I get the distance. What do? I set cur XY for the device context, and then the draw it. Maybe I want to get rid of this, but it's kind of deluxe. So right now the sprite draw, when it goes into its individual vector drawing, then it each one of these plots, this is like for plot a point, each one of these plots in the graphics API for device contexts, it records the locate nearest. You see this thing right here, flag locate nearest? That calculates every time it draws anything. If the locate nearest is set, it sets the element number and the nearest. Okay, so that was the device context nearest element was set here. And where did we set the locate nearest flag? Oh, we set the locate nearest right here. So that set the locate nearest for the device. Oh, that's pretty crazy, but whatever. Anyway, so that's how that works.